you have the survey, the underwater survey. On the other part, you have the veterans, very important, a lot of emotion through the veterans. And the third part is our part, our 3D engineers digital mock-up. And I will just continue to explain a bit more this project, because as Mehdi started to explain, the survey revealed a lot of incredible works, very incredible imagery, submarine imagery with a lot of tanks, Sherman tanks, a lot of huge ships, LST, Liberty ships, that have never been rediscovered since the D-Day, but this remains are the only biggest part and the biggest vehicles of the D-Day. Many of the rest, many of the other vehicles of the other innovation have already disappeared. So underwater we just see a very small part, we can just see rediscover a very small part of what had been created for D-Days. That one of the incredible tank, a Sherman tank, and it's just a small part of the testimony, in fact, that have been created. And only 70 years ago after D-Day, we are already losing this memory, losing the vehicle, losing what the innovation was at this time, what had been created. So from that, we decided to recreate 3D digital mock-up. I have a very short video about the veterans, and it just to show you the submarine imagery.
Submariner Jim Booth has returned to northern France, where in 1944 he had an instrumental role in the success of D-Day. Today he is standing where he, on the eve of D-Day, saw German troops relaxing.
We saw the soldiers playing football, yeah, that's right. Yeah, you know, that's the day before actually, so they didn't know, did they, what was coming? It's a hell of a time ago, isn't it, 69 years? But obviously it is emotional, very emotional.
Jim's was one of two X-Craft submarines that would help British troops find the right spot to land on the beaches. At the optimum time, they would have to surface and erect a light shining out to sea to guide the landing craft attacking Sword. 70 years on, Jim prepares for another mission.
Put yourself towards the bow. Like this? Yeah. I haven't been in a submarine since. No. Which is going to be amazing. Absolutely amazing. I'm really looking forward to it. It's tremendous excitement. Really, it's going to be marvellous.
For the first time, historian Nick Hewitt hopes to discover what it was really like to be an X-Craft crewman on D-Day.
See? Yes. That's amazing. So when did you leave?
On the evening of the 2nd of July in X-Craft 23. We sailed very secretly from the Isle of Wight.
So there are 5 of you in total?
Yes, about it.
Jim's X-Craft sub was only 15 metres long and 2 metres wide. It had the same diesel engine as a London bus. Conditions were cramped. During daylight, the X-Craft stayed hidden on the sea floor, close to the shore. After dark, they surfaced, extended their aerial, and listened for a coded message on the BBC that would signal the start of D-Day.
And was there a particular time you'd been briefed that you had to go up at a particular time to...
Yes, it was the old-fashioned 9 o'clock news, the BBC home service, it's like BBC One. We had a written code which you could, the things that we said during the news, then we knew there was going to be one of these funny little messages.
Submariner Jim Booth has returned to northern France.
So this guy was an incredible veteran because he's 93 years old, and every day he go jogging on the beach. He's in perfect health, and his story is really crazy, and many of those veterans have crazy story about what they live and what they do for D-Day. And on the other side, we are, as an engineer, we wanted to work again about the legacy of industrial patrimony, and we wanted to work on several vehicles, several icons of the D-Day, to recreate them, to make the digital mock-up, to make it understandable more easily for everyone. And for us it was a real tribute to the engineer of nowadays, to the engineer of the D-Day, that really help and make the difference during the D-Day. So understanding the ingenuity and the technological innovation was really important for us. It was our main goal during this project to understand at each part that we work on what is the innovation and how the engineers invented new technology or new things. And the first job, the first instance we work on was the Waco Glider CG-48. It's a very specific and interesting airplane. In fact, it's a specific airplane because it doesn't have motor. It's a glider, so it's completely silent. And one of its particularities, it's made of wood and fabric. So, as other vehicles, that explains why we can't discover one underwater, why they all have been destroyed or disappeared or destroyed through the time. And it seems that there is no Waco glider left today, and instead, but more than 10,000 were products, so a lot of were products, but most of them were completely destroyed. So, as none was remained, we had to start our work by trying to find the good references, to have the best digital mock-up, the more precise, the more accurate digital mock-up. So, through another video, another extract of the movie, you will see how we work, and I will explain a bit more each step of our work, how we work, how we try to find the better references.
Not the Trojan horse, but on the night before the invasion, another wood vehicle was slipping behind enemy lines unnoticed, under the cover of darkness. There are two large rivers that cross the road between Normandy and Paris, the Caen Canal and the Orne River. Intelligence revealed that the Germans had mined a bridge over the rivers and were prepared to blow them up, trapping the Allies on the beaches. It was urgent to get men behind enemy lines in order to secure these strategic targets. But how do you do that without modern Apache helicopters? One possibility was dropping paratroopers, but loud airplanes could alert the Germans, giving them time to blow up the bridges. So instead, the job fell to men like Kermit Swanson, a farm boy from Minnesota, who was trained to fly a silent wood glider behind enemy lines.
Our mission was to fly that glider over the land and try to keep from killing ourselves. If we did, we had completed most of our objective.
The objective was made more dangerous by the landscape of Normandy. This farming region is known for its patchwork of small fields, with fences formed out of a dense hedge of rocks and trees. The plan was to land in the cover of darkness when those hedges would not be visible.
You couldn't see because it was dark.
The gliders could carry 12 men, or even a jeep, land and jump right into action, if they landed safely. These planes were made mostly of wood and fabric, designed to break apart if they hit an obstacle.
It was terribly dangerous to fly a glider. It was dark, it was overcast, you were having to land into the little small fields. The only thing that protected you from being crushed into a tree was like a 3/16 inch plywood. I don't think anyone would want to be going 90 miles an hour and crash into a tree with only plywood as a barrier.
The gliders would be towed across the English Channel by C-47 planes. When they reached the drop zone, their tow rope was cut. It was expected that these fragile planes would only make one trip, and it seems that's the case for many of the men. The head of airborne operations for D-Day predicted in a letter to General Eisenhower that 70% of the gliders would be lost, and up to half of the men. But getting a working high-tech model from the poorly preserved World War II era blueprints was impossible.
As soon as we zoom in, we cannot read all the dimensions, so it will be quite impossible. Okay.
So the Dassault engineers came to the Fagan Fighters World War II Museum in Granite Falls, Minnesota, to use a laser technology to measure this meticulously restored glider. The process is similar to the multi-beam sonar on the Magic Star, but this machine takes exacting measurements with a laser instead of sound waves. More than 2 billion measurements are recorded from different angles to create one precise digital replica of this vintage plane.
We can turn around, we can zoom in, zoom out, go inside the cockpit. Yes. Let's see.
That cloud digital model can then be put to the test.
The first reaction I had is to say, I will never go inside one which is flying because it's so dangerous.
This plane that is made out of wood and fabric could transport up to 12 men or even a jeep.
Can we try to land on the left?
Today, that World War II glider flies once again, this time much more safely, in the world of virtual reality.
Now you can control through the joystick. And we can see when you mix a lot of different references. So that way it was a long way. We start from pictures, but after that we find digital blueprint of the Waco. So on one way, I remember exactly, it was in September when I received 4 DVDs on which there was a complete collection of the digital blueprint of the Waco. So I was very, very happy because it was just like a treasure for us. But as soon as I opened the folders, I saw that kind of quality of digital blueprint. So as you can see, it's just a copy-paste of what we received. It's unreadable, really unreadable. So we were completely terrified because we can't use this because we need information, clear information like measurement, size, all the different parts that are inside the glider are listed normally, for instance, in this sheet. So it was useless for us. So we were very disappointed, and we needed to find another reference. So we moved to Washington, D.C., and there we finally see the original microfilm that were photographed at the end of the World War II. Just want to go back on this one. The problem was very simple. The blueprints in their original format are very huge format, much more than a regular paper sheet. Sometimes it could measure more than 1 meter, and they just digitalize and put this huge format in very small A4 paper or format of later. So we lose all the information during the digitalization process. So we were very surprised that just nowadays, sometimes people doesn't master the digitalization process, and for us it's very important to keep the original format, the original sources, references, and the original blueprint. So we spent many days in the archive of the Smithsonian in Washington just to watch on this very old machine, 10 years or 20 years old machine. But it's very useful because it's still working pretty good, and it allowed us to watch not all the microfilm, but many different parts of the microfilm, and then we zoom in on each microfilm and just note also the measurements that we needed. So it was also one of our references, a very useful references. And as we mentioned in the movie, we move also to Granite Falls. It's a very small town in Minnesota. We moved there because there's a museum of old airplane of the World War II, and there 10 years ago passionate people just wanted to recreate, to reconstruct a rail glider from different part of old glider. So we were very lucky to work with them, to move there, because we were able to make a laser scan of the real object, which allows us to have all the measurement, a point cloud of all the measurement of the real object. So it's very useful for us because we can mix the pictures as a references, the original blueprint, but also not a real Waco glider, but a real object of a Waco glider, not a glider of the World War II. So it's by mixing the three different kind of input that we can have a really accurate 3D digital mock-up. So enough of blah blah. Now we can switch to a live demo, because I'm very proud to show you our result of many months of work. So my colleague Olivier, who is in the backstage, we will switch to the computer, and as soon as you are ready, Olivier.
Hello, Nicolas, can you hear me?
Yeah, perfect.
Okay. Hello, everybody.
And through this demo, so you don't need your 3D glasses, it's in 2D. So no need of 3D glasses. And the idea of this demo is that you will understand much more how we work, which tool we use, and also I will just explain a bit more about the Waco glider. Instead of using pictures, static pictures of our movie, we will use our favorite media, which is of course 3D. So
okay, Nicolas.
Yeah.
So I propose to start with this simple 3D view.
Yeah.
So this 3D view is made of the drawings, 2D drawings,
Yeah.
the blueprints you have in your document. So this is the front 2D drawing, and this is the bottom 2D drawing. So now I'm going to turn on and activate the 3D mockup.
So here we put the drawing, the bad drawing, just to show you how the shape fits, but this one was, of course, unreadable. And now with the digital mockup, we can see that it fit perfectly to the blueprint.
Nicolas, if you agree with that, I would like to take 1 minute to explain what we have on the screen.
Yeah, for sure.
So what you see here is software to create and simulate 3D products. And you will see how this software is used by the industry when engineers can create and simulate big assemblies. So this software is CATIA P6. And I want to take 1 or 2 minutes to explain what you have on the screen. Actually, there are 4 main areas. The first area is the 3D window. You see that this 3D window is very big. It's more than 80% of my screen, which is really cool because I have a lot of space to manipulate and simulate and work on my 3D. Then the second area is this one on the left, where I can select in a list of workbenches which workbench I want to use. Depending on the job I want to do, if I want to create, I don't know, a sheet metal part or an electrical part, or if I want to do assemblies, or if I want to create drawings, or if I want to, I don't know, simulate a kinematic mechanism, I can pick up from here the workbench I want to use to do that, and then here at the bottom I will get all the functionalities of this workbench to do the job I want to do.
So on the left side is your toolbox for working on creating 3D models. That's right?
Absolutely. Yeah. So the third area is this one, this toolbar where I can pick up all the functionalities to do what I want to do. And finally, the fourth area is this one, and this one is maybe the most important one. On the left here, what you can see is the product structure of my mockup. It's a kind of hierarchical tree, you know, where you have nodes and sub-levels, and at the bottom of the levels you have the leaves. And for example here, I can expand the different levels. And you can understand the complexity of the way the mockup is built with all these levels and sub-levels. And I can even go down to the levels and go to the screws. You can see here, for example, if I pick up this screw, I can see it in the product structure. It's here.
So it's a complete list of all the different parts of the digital mockup.
Yeah.
So we even have the screw.
Yeah, we have the screws. Yeah.
And maybe we can now see a bit more about the Waco glider.
Sure. So, Nicolas, while you are explaining, I'm going to remove the skins so that you can see the complexity of the mockup and the details. So I'm going to remove the skins of the fuselage first, and then the skins of the wings.
Okay, because on the outside, the plane seems to be very simple, very rough, but when we will remove the skin, which is, remember, fabric, you will discover a lot of different, very small parts that are mainly made of wood, and it's very interesting because at this time there were 16 different companies who work on building the Waco glider, and many of these companies were companies who were very well skilled in creating things in wood. So, for instance, we discovered that Stenson, the company who build piano, build a lot of Waco, or also General Motors, Ford Motors, sorry, work on the Waco too. So now we can see on in the wing all the different parts made of wood. It's something like 20 meters wide, and the weight of the Waco anti-load is about a bit less than 2 tons, but it could load something like almost 4 tons. So
okay, Nicolas, if you're okay with that, I propose to focus on the cabin.
yeah,
I'm going to remove the skins as well.
okay. So you will isolate the cockpit.
Yeah, right.
Okay.
Yeah. So let me
We'll make the view more clear.
this.
And for the cockpit, we'll see we have 2 seats, one for the pilot, one another for the co-pilot. They were seated at the front, of course. And you can see the tubular structure, the metallic part of the cockpit, which are almost the only metallic part. Some are in the cockpit and other in the back, where the soldiers were sitting. So maybe we can switch to the rest of the Waco, and just to show how the cockpit can be opened. At this point, it could move and lift up. Maybe you can show us how the cockpit can be opened.
Okay, so here I'm going to replay a kinematic mechanism to open the cabin. Oops. No, there is an error, so okay, no, so I'm sorry, I'm not going to do that. So maybe we go inside and I will display inside the cabin the seats.
Okay. Thank you, Olivier. We will switch to the next vehicle, the LCVP, and we will be able to see another live demo with the LCVP too. Thank you. Vous pouvez basculer sur ma yes. So the other iconic vehicle is the LCVP. So for the LCVP, we work the same way, trying to find a lot of references. The LCVP is both on one way we have the glider for the aerial troops, and we had also the LCVP for bringing soldiers close to the enemy in front of him, directly on the beaches of Normandy. So this LCVP, this boat was very rough, just like the glider, made of wood, and a lot of different units was produced. But like for the glider, non-LCVP remains nowadays. And so it was a bit difficult also to have a lot of references. So we needed to move to New Orleans, where the LCVP was created by Higgin Boat Industry in New Orleans, because just very close there is the bayou, and in the bayou they use a lot of wood with hull with very flat, and the LCVP is directly inspired by that kind of boat. So we find some of the original blueprints that are in the University of New Orleans. We scan it and we use it directly to recreate our digital mockup. The interesting part with those blueprints is that they start in 41 and ended in 52. So it gives you an idea of how long the LCVP was used, how many iterations was created by the engineers, because through the time, through the usage of the LCVP, they made improvement. We'll see just after a lot of improvement on the road to make it better and to adapt it to the different situation. We find a LCVP, but not a real one from the World War II, just like for the Waco glider, it was a restored LCVP. It was in Normandy, in 40 ans. So we move there and we make also a 3D laser scan that this part of the picture. So we took a lot of measurement and we mix it again with the original blueprint. So Olivier, if you are ready, we can switch quickly to the LCVP. And I just want to show you very briefly the main innovation which are in the LCVP. As I mentioned, it was made of wood, mainly of wood. The only part that was created in a metallic part, a steel part, was the gate, the front gate. And this front gate was created to open almost automatically when it landed on the beaches. That's the very specification of the LCVP. Olivier, can you show us the digital mockup and go directly to the back of the hull, please? Because yeah. Perfect. So the main part, the most interesting part of the LCVP is underwater. It could land on the beaches in less than 1 meter of water, so it was very important because to avoid the soldier to fall into the water. And the hull is very specific because it's hollow to the propeller here to be always into the water. And we rediscover through the blueprint innovative concept like this small hole in the rudder, which could be used for maintenance on the propeller, and also a second rudder, a small part over there, which were very complicated for us to understand only on the blueprint because it was in 2D, and we just understand how it was used when we see it in the digital mock-up. This rudder is very smart because when they needed to go back, when they unload the troop on the beach, they needed to go back and took other troops on the ships. To have to be able to drive the boat, they added the second propeller, the second rudder, to make the boat more drivable in the water. And also the back, the shape of the back of the LCVP evolved through the age, evolved through the delay, because here we have two edges. It's to break the wave where the LCVP go back backward in the water. Thank you, Olivier. And now I will talk about. Can we switch to my presentation? Switch back to my presentation, please. Third of it. But it was a very, very important part of the D-Day, or just after the D-Day. Just to replace in the context of the D-Day, the main harbor in the city were occupied by the German, and Allies have to create their own harbor to be able to unload and to continue to have troops, materials, oil, etc., just after D-Day. So one of the biggest challenge was to create from scratch, for the first time ever, an artificial harbor, not in a city, not in a harbor, but just on the beach. So that's the result of a very impressive and huge structure. So this is a panorama of the beach of Arromanches, where you can see the artificial harbor. And as for the LCVP and the WACO, we also use a lot of archive and picture from the D-Day. And I will show you the third and last video to explain a bit more the mulberry.
Mulberry B for the British and Canadians were made up of 19 kilometres of steel roadways, codenamed Wales, that floated on huge concrete pontoons. Each section of Wales would end at an enormous pierhead that rested on the seabed.
Dad went and produced some working for us in 2 weeks.
The harbours were made up of tens of thousands of pieces that were shipped and towed over from England as soon as the beaches were secured. Then this huge jigsaw puzzle had to be assembled and be fully operational within 2 weeks of D-Day.
It was a tremendous achievement in engineering. I can't think of anything on such a scale that's been achieved so quickly.
But on the 19th of June, a raging storm devastated both Mulberries. Over 800 ships were lost, as much damage as the Germans had inflicted since the start of the landings. Mulberry A was so badly wrecked that the Americans decided to abandon it completely. Now the whole weight of the invasion fell on the Anglo-Canadian harbour. And it held firm. Soon 9,000 tons of cargo was moving through the repaired Mulberry B onto the mainland every day. While the modern-day expedition is locating surviving sections of the Mulberries long since thought gone, present-day engineers from Dassault Systèmes, led by Nicolas Serikov, search for the original engineering drawings.
On the spud pier,
they have a plan to carry off a technological first. A high-definition, 3D virtual replica of Mulberry B. If they succeed, Tim Beckett will get the chance to travel back in time and walk where his father walked 70 years ago.
Let's have a break for the advertising. No, it's a joke. We will continue the video.
After hundreds of painstaking man-hours, using the original design plans, the Dassault Systèmes design team have managed to complete a detailed and accurate reconstruction of the Mulberry Harbour off the coast of Arromanches. Work that has helped them understand for the first time the true engineering brilliance of Alan Beckett and his team.
On a vraiment pu comprendre les solutions qui ont été inventées par les ingénieurs de l'époque. Aujourd'hui, on les redécouvre avec nos moyens technologiques. Et je crois vraiment qu'en fait, on peut dire que ces ingénieurs ont inventé le débarquement.
Nicola has invited Tim Beckett, a bridge engineer himself, to step back in time and walk in his father's footsteps along the roadways conceived by his father.
That was, yes, he was living on one of these. You go down?
Yeah.
That's really excellent. Were we there, weren't we? We're just like being there. Ah, well look. So this is really very good.
Mulberry B for the British and Canadians will
And now, just to continue to speak about the mulberry, I invite to join me on stage Tim Beckett, who is the son of Alan Beckett, one of the most important engineer who create the mulberry bee. So he's a specialist. He is a specialist of the mulberry bee. Hi Tim. Thanks for coming.
You're welcome. It's good to be here.
And I will let you just introduce yourself and explain to us briefly.
Yes, my father, Alan Beckett, he was, I suppose, key to the design of the Mulberry Harbour. He designed the floating roadways. He worked on it for several years. He went over on D-Day +1 with it and supervised the installation, and also acted as liaison with the American harbours. He travelled to and fro. I think he was very proud that the Americans, albeit by cutting corners, got theirs up and running in 3 days, and which was essential for the support of the invasion and all the supplies, tanks, equipment. The British were a bit more methodical, and they took a week or so to get theirs operational. Then the British one was put together better and survived the subsequent storm. I followed in my father's footsteps. I'm a port engineer, I'm a consultant in London. We work all over the world, but in several schemes we've still used the inspiration of Mulberry, landing things on beaches. We never have the budget that they had, and we usually have a bit more time than they had. But nevertheless, there's plenty of lessons there for engineers today to learn from. And I'm delighted that Dassault created this visualization of virtual harbour. And I've been to Aramonge many times, but I've never been to Aramonge and seen this. And you really do get a good feeling of how it was 70 years ago. My father was there.
So maybe we can switch to the 3D demo and go back 2 times at Aramonge in 44. So now it's time to put your 3D glasses, and if Olivier is ready, we can switch. Can we switch off the light, please, at the stage? Thanks. So here we are just in front of Aramonge that you can see in the background, and the structure just in front of you is Mulberry Bee. So maybe, Olivier, we can just see the first part, what we can call, what is called the Phoenix Caisson, because one of the first things to set up for this artificial harbour was to create an artificial lagoon to protect the boat, in fact.
Yes, it needed calm water. The first thing to go over was the block ships, which are just off to the left of the screen there. The block ships went over under their own steam, They could steam at 12 knots. So they arrived on the day after D-Day. The Phoenix caissons here, which also acted as breakwaters, could only be towed at 4 knots, so they turned up a bit later.
And they are made of concrete.
They're made of concrete blocks, and they're bigger than them. They were used in deeper water than the block ships. And also we didn't have enough block ships. We were rather short of ships by this time in the war because the Germans sunk most of them. And there was a bit of reluctance to give up too many merchant ships, seeking merchant ships for us. But the block ships were sunk while under fire, actually, still from some of the German forces. And I think when the first ones went down, they thought they had sunk them, not realising that they were deliberately sunk.
And you told me a very interesting story about those block ships, because it was like a houseboat.
Well, yes, yes. My father camped out in one of them. In fact, I think most of the team of engineers building the harbour lived on the ships because they felt that they were a bit more independent there than ashore in camp. So they could do their own thing.
Yeah, we are almost at 2 kilometers away from the shore, so yeah, it's very far.
Yes.
And it was an easy way to reach the other artificial harbours, the Mercury 8, which were destroyed during the storm.
Yes, well, my father went to and fro from Mulberry on a motorbike, but the roads were very narrow and they'd been widened with bulldozers. So going one way he was on tarmac, and coming back he was on rubble. So he used to ride back on the wrong side of the road. I think nearly got killed. So he put in for a jeep and was given.
And Oliver, can we go to the pierhead pontoon, the second technical interesting thing? The pierhead pontoon is, in fact, after creating a lagoon, they needed to unload and to have specific structure to unload all the ship, and that's the role of the pierhead.
Yes, this all comes from Churchill's memo. Churchill had said that they needed piers that go up and down with the tides. These pierheads were unique at the time in that they were on spud legs, and they partially...
That's that's a grey...
with the vertical legs.
Vertical legs.
So and then they partially lift themselves out of the water on cables, so that each one has got a little winch house in it, and you can see the cables there. So when they lift themselves partially out of the water, the quite large ships, the Liberty ships that we see manoeuvred there, can berth alongside them, and then unload using the ship's cranes directly onto the pierhead. The pierheads weren't meant to be lifted fully out of the water, but during the storm that occurred started on the 19th of June, some of them did lift themselves right out of the water, out of the waves, and were saved from damage by doing that. But I'm not sure they did so on the American.
And when they unload the cargo, the idea is to reach the land, reach the village, so they needed to have a specific structure for that. Is that the roadways?
Yes, they had the floating roadway, codenamed Whale, which was my father's design. They actually had 3 test prototypes, which they installed up at Garliston in Scotland, without any protected breakwaters. And after some storms, this design, my father's design, was the only one that survived. So they adopted it, and they made 10 miles of it. It's the most unusual floating roadway, in that it can withstand very rough seas. so these bridge spans have the ability to twist up to 45 degrees along the length of each span.
That's why we can see the roadway moving left and right, depending of the sea.
That's right. And of course, under the influence of getting run over, and they're 80-foot spans. They're sitting on pontoons which are called beetle pontoons, and they could take the largest load they had to take was a Sherman tank, which weighed 40 tons.
And we see different kind of little caissons. Some are in concrete and others are in steel.
Yes, there was a great shortage of steel in Britain during the war, so there wasn't. My father designed the steel pontoons, but there wasn't enough steel, so they had these concrete pontoons as well, which were quite fragile. Quite a few of those were lost getting across the channel. The steel pontoons again of two types. We see ones here with legs on them.
What were used for?
Well, the reason this is so long is because we've got a very flat beach. The Normandy beaches are extraordinarily flat, which is why they weren't so heavily defended. The Germans never thought that anybody would land over such difficult beaches and then be able to load cargo so far over a tidal beach. Now, there's also rocks on the beach, so at low tide, this pontoon will sit on the rocks. So it had legs, so they could be landed on the legs, and then at low tide cement bags would be put underneath it to create a bed.
Maybe, Olivier, can you just go up a little and just show us how the tide affects on the harbour, and maybe go a little bit further on the front. Yeah, thank you.
So it's going to very quickly.
Maybe go to the limit of between the sea and the beach. Can we move a bit further? So we can see that very interesting because we see it's mainly made of sand, not really rocks.
Well, there is sand, but I think there was the Calvados reef as well, so there were rocks there. The Americans had first choice of which beach to land on, and they chose Omaha. They may have regretted it later because it was well defended, but they chose it because it had better water and it didn't have rocky foreshore. So the British were with the site with the rocks.
And Olivier, just on your left.
Yeah.
Olivier, yeah, just on your left side.
Yes.
Can we go underwater just to see the legs of the caisson? Yeah. A bit further we will see the leg and also the kite anchor, which is very specific and interesting.
Yes, my father had to then design.
That's the legs.
These are the legs, which were trackable. In order to hold it all in position, it needed anchors, and the estimate was that a 20-ton holding power was necessary. And with the safety margin was actually around for 30 tons. There was no anchor around at the time that could hold this sort of load and still be, man-handled without heavy lifting equipment. So my father invented the kite anchor.
Yeah, it's on the other side. So
Yeah, I know. Yeah.
I think we're going to go and see that, which could be positioned.
No, it's not here. Over
there.
Yeah. You missed the right one.
But how is not the right caisson?
Yeah. No, doesn't matter. Okay. And So maybe we can just go back to the village and have an overview of the panorama.
Yes, I think what this does do is show you how huge this harbour was. It was the size of Dover Harbour, and it was essentially there. All the principal elements were there in a week, which is an astonishing feat.
Do you think it could be possible to construct such a structure nowadays?
Well, I don't think we'll ever have to construct one today. Mulberry Harbour is a bit like the Trojan horse. It's an idol that can only ever be used once in the history of warfare. The remarkable thing was that it was kept a secret. Although the Germans knew that all this equipment was there being prepared, they thought that it was all for repair of harbours. They never dreamt that it was to create a whole new harbour. Once you've done it, that element of surprise could never be achieved again. And anyway, we wouldn't need to do it now because we have helicopters now.
But we have, as a legacy, we have a lot of innovations that we still use nowadays. I'm thinking about all the floating caisson in every harbour where boats are attached.
Yes, there were lots of innovations that are still used, particularly roll-on, roll-off ferries that were really pioneered here. With the floating beaches, big tanks ashore. The jackrack pontoons that we've seen, they're used widely now for contractors, crane pontoons. Floating roadways, there's a few of them around. None designed to cope with sea state whales. And there are an awful lot of the whale bridges we used to repair bridges in France, static bridges in France after the war. Some are still in position.
And nowadays there only remains of this artificial harbour as the caisson, phoenix caissons that we can see from the coast of Armand. Thank you very much, Olivier. Thank you very much.
Thank you, Nicola.
Explanation and all your support during this project, because I remember